I gotta say I'm really impressed with their software. It was very easy to integrate. It's pretty nice actually. So the first thing you're gonna do is go to website. This is assuming that you're logged in. You come down to the downloads folder, PlanetCNC integration package. So we'll download that. Configuring X, Y, and Z positions. We're going to go over this in the video a little bit, but this is a good page document for all of that. Some different things. So check all that out to gain an understanding, because I'm going to move through this fairly quickly. Okay, so we've got our package downloaded. Now there's a couple things that need to be done manually. So if you extract it just right in the downloads folder, we'll just extract that right in here, and then it opens up. This button left text file is going to put some buttons on the left side of the UI, and it's kind of handy. Let me open this up for you. It's got some different things. Now you may already have a buttons left file. And okay, so here's the button left that that I've created that I'm going to use. So it's very simple. I really love PlanetCNC because they really up to date, modern, and integrating customization is super easy. This button is going to allow you to set up the ATC. The hood button is going to open and close the dust cover. And then I've just got this G code on these buttons to drop the current tool from tool 0, and then pick up all the other tools. We're going to copy and paste that into the proper place, but I wanted to show you the parameters.txt file. Now the parameters.txt file, I just started using it, so a lot of this stuff isn't populated, but you may have this already, your work offsets and everything. So what you would need to do is to take and copy all of this and paste it. Okay, so we come to PlanetCNC, and we're going to go to Profiles. Whatever profiles you're going to use for the ATC, you're going to want to go into that, and then open up your parameters.txt file. And of course I've already got these in here, but you'll just paste them right in at the bottom of the file. So now if you choose to use the button, but we're going to take that file and another thing, you can just take and add this all in if you've already got a buttons text file, and just add it to that file. But assuming you don't have one, we're just going to paste it right here in the profiles and whatever profile you're using. Okay, so back to this, go into scripts, and you're going to copy these 3 M codes, G codes, M6, M900, and M910, and we're going to copy that, and we're going to come back to our default, open up scripts, and paste those right in there. Okay, so that's all we have to do with those files. The one thing about the outputs for controller board is I needed to add this 5-volt relay up at the upper right hand corner. Now that gets powered with 5 volts and the common, and then this purple wire is the output. That's what's going to trigger the dust cover. I've got it wired on the normally open side because when the signal wire is pulled to ground, that activates the dust cover to open. The MK34 board is really nice. I'm assuming it has pull-up resistors because I was able to wire the infrared sensor directly into an input, and you can see that over on the right-hand side. I've got the green wire in input 1. The yellow wire is coming from the 3D probe tool setter, and I've got that wired to input 2. So let's go to PlanetCNC. What we're going to want to do, if we come down here, now if I click the hood button, it's not doing anything. I don't actually have the dust cover on this, so I like to leave it off when I'm setting things up and getting things configured, but with the arms on, you'll be able to see that it's opening properly. And one thing that can also happen very easily is to wire up a rocker switch to the signal and ground wire for the dust cover, and you can open it and close it manually just by flipping that rocker switch. You know, the signal goes to ground to open the dust cover, so there's a lot of different ways that you can operate it. Another way would be to have a limit switch or a proximity sensor on one of the axes, and as the machine moves over the axis, you can trigger that output to open the dust cover. So if you go to your settings, so your tool offset measure length wants to be set up, and you want to set the position of your tool setter here. And I'm not 100% sure, but I'm assuming that the Z position is where it's going to start seeking from. So if we go down to tool change, this is what we want to see in the tool change section. We want the tool change enabled, skip same tool enabled. Spindle check, in my mind, it's really not that necessary, because in the middle of a program when you're changing tools, you're going to have a new tool and it's going to have a new S RPM value when it starts out. So I always like to keep safe height at 0, especially for testing. If you don't have the IR sensors, safe clearance at 0 is always good for every move, just because, you know, it's just safer that way. Position enable, you don't want that checked. Now, here's the action tabs. It'll show them. If you have message, it's going to pop up a little message, tool change or something. I can't remember what it says. And then you hit cycle start to continue. If you put a pause, it's just going to pause it, and you'll have to click the pause button to start up. I'll show you that. Actually, I'll show you both of them when we start. So I'm going to select those, but these can be deselected. You know, it's all what you want to do. You want to make sure that ATC is enabled, but the rest of this is going to be completely ignored, so none of that matters. So once you've got that set up, then you click on the ATC, turn that back on, and so we're going to find our positions. So I've got this magazine set up on the X-axis, so I'll click X, and pocket 1, I've got I want pocket 1 to be next to the tool setter, so from pocket 1 to pocket 2 is a negative direction, so I'm going to click negative. Now, you can have pocket 1 be at either end of the magazine, but it's got to be on the end, because pocket 2 and subsequent pockets get calculated from that pocket 1 location. Now, this is a 6-pocket magazine with a tool setter, so I've got a pocket count of 5. Pocket offset, this is a ER11. Pocket offset for ER11 is 38 millimeters. Just to point out, I am in native units in millimeters. for this setup. If you are in inches, then you will record in inches. If you're in millimeters, you'll record in millimeters. So that makes it easy. Just make sure you put the values in of your native units. So now I don't have a hand wheel, so this might be a little bit slow, but let's see if we can move into position here. We close out of this for a minute, and let's find pocket 1 here. Now I actually know where it's at, but we're just gonna find it manually. So we're gonna bring it over, get it close here. Bring Z down. Oh yeah, Y needs to move up a little bit. Okay. And we can bump her in there. Alright, let's see here. That looks good. Y. That looks good. Now, let's go ahead and turn the spindle on. And I don't want to turn it on at 24,000, so we'll just go S2000 M3. Get the spindle running, and now we're going to just lower down into the pocket. And what we want to see is that we're not rubbing anywheres. And I'm going to show you what happens. I'm going to show you what you don't want to hear. Okay? When you make connection, engage, you want a solid smack. So if you hear any kind of noise like that, any chattering like that, you're not engaging fully with the socket. So basically right now, we're just making sure that we're not rubbing on the sides of the pocket, and we're centered up. And turn the spindle off here. And now we're going to bring Z down. And we're going to bring it down so that, and I know you can't see it here, if you look at the website on the X, Y, Z positions, it will explain it very much better. But basically, we want with the, and it's very important that you have a cutter, you know, a collet nut and clamping assembly all on the spindle when you do this. Because if you don't have a collet nut in there, it's going to spin up too high and it's not going to engage the clamping nut. So this looks like a good position. You want it to basically be where the clamping nut would sit in the pocket at rest. So this is what we're going to call our Z engage. And we're in position. We're in machine coordinates, always in machine coordinates. So now we can take and copy these numbers over. 279 for X, 189.1 for Y, and Z, we're going to call that negative 92. Now, Z move to load is going to be however high you want it once it's dropped off the tool. If you don't have infrared, I suggest it to be up quite high. I think when I set this up, I had set it up for, let me cancel out of this, hit OK. Speed this up a little bit. Okay, where are we at? Negative 51. I think I had it set at negative 30. Yeah. That would probably be okay. What you want to make sure of is that once you drop the tool, it's going to clear, the spindle's going to clear any tools that are sticking up. So we're going to set this, open the ATC back up, and I'm going to set it back to negative 30. It's a little higher, just for good measure. Engage feed rate, I'm going to set at 2,000. Load RPMs and unload RPMs 2,000. This is an 800 watt spindle. Larger spindles will require less RPMs. I've got a 4 kilowatt spindle with an ER25, and I think I engage at 1,000 RPMs on that machine. Now, spindles and clamping nuts are slightly different, so things are going to vary. I always suggest starting out with a lower speed and ramping it up until you get the torque on the clamping nut that you're looking for. It's the best way to do it. One of the biggest mistakes that people make is, and it's perfectly understandable, that being used to running your spindle at 12,000 up RPMs, maybe 8 or 10, and you go to a lower RPM, it's difficult to really judge where the spindle is actually spinning at if you don't have a tachometer or something, because if you try to engage the socket at 4,000 RPMs, you're going to destroy it. It's a common mistake. We're sending out the magazines with extra sockets now because we warranty everything. So rather than sending people out sockets at a later date, I just send out extra ones. Okay, so tool recognition, we're going to set that up. I've got that wired in. So we're going to enable tool recognition. And the IR sensor input is input 1. And we're going to check that now in a second here. Okay, actually, we're going to do that right now. So if you come over here to the I/O tab, you will see that when I block the sensor, it lights up input 1. Okay, that's what we want. When the sensor's blocked, you want to see that pin light up. Okay, now I've got the tool setter set to input 2. Okay, so those are working. Now I've got the dust cover set to output 1. So this is really handy. I got to say, I really like PlanetCNC. I really do. They've thought of a lot of stuff. So we can just turn that input on by clicking right here. Whoops. Yeah, I guess you can see that. Okay. So input 1, on, off. There we go. We know the dust cover's working on. or output, I'm sorry, output 1. So we'll come back to the ATC. We're going to enable the dust cover. We're going to, this is wired up on an output. If you wire it to an axis, an open axis, you just pick the axis number. Closed position is going to be 0. Open position is like 30, 38, I think, 35. You could play with it. And so that's that. Then the output, this is going to be the pin. So we're running the output, and so we're going to go to pin 1. And then the output dwell is going to be a little pause, and depending on how much clearance you have, you may want to give yourself more of a pause. And I'm just gonna put, you know, a 1-second pause there. Seems to be right. Now we've got everything. Everything is configured except for our zone 1 and zone 2 for the IR sensor. So we're going to establish that right now. So we've got a clamping nut and a tool in the spindle, and we're going to, diagnostic screen open, we're going to bring Z down. Let me slow this down a little bit. Whoops. Oh, numlocks. All right. Now, zone 1 with the clamping nut on, we want to just block the beam. So we're going to bring it down until we see that output 1 light up. Now, that is negative 59.1. I'm going to go a little bit lower than that just to make sure we're completely on the nut. So I am going to make that 60. Okay. And now, if we move up 5 millimeters, well, here, let me. G53, Z60, oh, negative 60, G53, Z negative 60. Okay, so we're going to call that for zone 1. Now you should be able to move 5 millimeters up, do a G91, Z5. 5 millimeters up should clear that pin, and it does. So 5 millimeters is usually a good difference between zone 1 and zone 2 for most of your clamping nuts, but obviously you can adjust it. What you want is zone 1 with the clamping nut on the spindle to block the beam, and then you want to just raise it enough so that it clears the beam, because if for whatever reason the clamping nut does not thread on all the way, you want it to be able to detect that, and we're going to show that. We'll go back to the ATC, and zone 1 we have at negative 60. Zone 2 is at negative 55. I'm just going to double check all this since I'm doing this live here. Crashes are never any fun, but I think we're all set. We're on the x-axis, negative from pocket 1 to pocket 2. We've got 5 tool places. Pocket offset for ER11 is 38 millimeters. ER16 is 42 millimeters. ER20 is 45 millimeters. ER25 is 52 millimeters, and ER32 is 60 millimeters. We've got X pocket 1 location, Y pocket 1 location, Z engage, move to load. Everything is there. The only other thing that we want to do here is, so here's our tool table. I've got 0, tool 0, number 0. This number can be any number you want to give it. The slot pocket number is the number that corresponds to the pocket in the magazine. So this allows you to have different tool numbers that will be associated with a particular pocket. Okay? Now, by setting the slot pocket to 0, actually I don't think that's what here. Let me look at this. Tool change, custom. Oh, we got to click on, okay, so we've got, for tool 0, I've got it set up so tool 0 over here on the buttons on the left, if I click tool 0, it's just going to drop the current tool. Okay? And you can customize this and set it up however you want. But I don't want it to measure tool 2. So I've got the skip tool measure there. None of these are going to be positions are used for any of the tools. Now if we go to tool 1, you notice that it doesn't have the skip tool measure on it. So I've just got these for tool number 1, pocket 1, tool 2, pocket 2, tool 3, pocket 3, tool 4, pocket 4. Now, so we should be all set here, and we're going to just go ahead and drop tool 1. So I'm going to click the T0 button. And did I click it? We're not doing anything here. Oh, we've got tool 0 in the spindle. Okay, so, but we don't have tool 0 in the spindle. We actually have tool 1 in the spindle, but because we're setting this up, PlanetCNC thinks it has tool 0. So what we're going to do is we're going to type in M61Q1. M61Q1 is going to change the tool that PlanetCNC thinks it has to whatever Q number you choose. Okay? So now it has tool 1, and we're going to go ahead and drop that off. And now remember I selected the message and pause. So the message comes up, change tool 1 to tool 0. Okay. Now I've also got the pause selected, so it starts out paused. Click that. And now this should drop off tool 1 if we've done everything right. Looking good so far. And success, except we do have a problem here. It failed to unload. Now, it didn't fail to unload, but it thinks it failed to unload. And why is that? Let's find out. Okay. Our infrared sensor is working. Okay. I've done something here. Let's go back here. Infrared sensor input 1. Okay. See, I forgot something. Beam broken state was not selected. See that? I forgot about that. So, when we block the beam, it's active. So we need to click active. And now we should be all set. So let's just go ahead and pick up tool 1. And what I'm going to do to make sure that it's working is I'm going to block the beam. Okay, actually, you know, to save time, I'm going to go back to my settings. And I am going to turn off the message and the pause. So it's just going to make the tool change as soon as I select it. So let's go ahead and pick tool 1. Opens the dust cover. Now I'm going to keep my finger on the button because I'm pretty sure the tool setter is going to work fine, but alright, we're good. I'll tell you, I've worked with so many different controllers and whatnot, can't tell you how many times I've thrashed stuff. So now, what I want to do is, I've got tool 1 picked. I'm going to change to work coordinates. And I am going to move to, let's speed her up here. And let's go out over the table here. It's kind of centrally located. And I'll bet that, well, let's just go to Z0, see where we're at. Z0. Oh yeah, moving really slow. Alright. That's okay. Now I'm going to take my 1, 2, 3 block and we're going to get that set. Okay. I just moved it up a tenth. So we're pretty much right there. And I'm going to call that. Oh, let's see. Oh, yeah, I could do it like that. Okay, so we're going to call that 76.2. It's 1, 2, 3 block. So now we're in G43H1 because it set the tool length offset from the library. If I type in G49, which turns that off, now we have a different Z work height. Okay? So you want to make sure, now the M6, the tool change function will do this automatically, but you just want to make sure whenever you're, especially whenever you're setting your work Z, that whatever tool you have the appropriate tool height. So if I type in G43H1, because we have tool 1, it goes back to 76.2. Now, let's change from tool 1 to tool 5. Now, we get an error because tool 5 does not exist. Oh, here you can't see that. Tool 5 does not exist in the tool table. Okay. Tool 5 does not exist in the tool table, so we got to come back over to edit the tool table, and we need to add 5. Oh yeah, okay, here we go. 5, add. Okay. And want to make sure that, and I think this is the default, it's not going to put that up, so we should be good now. So, try this again. T5. Going to drop off tool 1. And the infrared sensor worked appropriately. Now I'm going to show you what happens. Simulate zone 2 being blocked. Or I'm just gonna show you here. So it actually blocked it at zone 1 because it wants to see it clear. Or actually it did block it at zone 2. Right, it wants to be blocked for zone 1. So you'll get this message. Pocket 1 failed zone 2, manually load the tool. We just click OK, and it will come over, measure the tool. Hopefully it's not going to bottom out. I think I've only got it set at 50 millimeters. I don't know if that's 50 millimeters, but nope, there we go. All right. Now we should be able to come back out over the table. Type in Z76.2. Let's forget to do a G0 there, but no, that's a little low. About 2/10 low. I'm not sure why. I think my wait a minute. Oh, my bits broke. Okay, that's kind of weird. Must have been broken in there. All right, so let's just go ahead and drop that off. And let's go ahead and pick up tool 2. All right, let's move this one out. I pulled that last tool out of a different rack, and I remember that I had crashed that one into a tool setter previously, and must be why it was broken. Z76.2. G0. And there we go. That's right. Okay, good. So that's basically it. It's all set to go.